Students, today we will start a new chapter called Work, Energy and Power. So students, in class 8 you have just understand little bit that what is work and what is energy and what is power. So they are the that are the basics of definitions and units, all the things. And my lecture also available related to the basics of work, what is the definition and units. Although I have, once again I will explain over here. So just do a little bit previous knowledge, just explain that what is work in our daily life. You know that work means all the physical activities, mental activities, everything what we used to do, that we will generally call as work. But student, in term of physics, you know that in term of physics generally we called work as W is equal to F into S. Okay, means if there is a displacement under a force, then is only work is said to be done. Suppose you are pushing the wall of your house. So students, suppose this is wall and you are pushing. Is there any work will said to be done? No. Because there is no displacement. S is equal to 0. General formula W is equal to F into S. S is 0 means W is equal to 0. Okay. So in the term of physics, we say that if there is a displacement under a force, then his work is said to be done. Okay. Otherwise, whatever you mental activity you are doing and you are saying that you are doing work, no, it in term of physics it is not work. Here also you are pushing the wall. Okay, your energy is losing. Okay, suppose you are giving force also, but as there is no displacement, in term of physics you are doing zero work. Okay, whether you are giving some force on it, but still you didn't have done any work, as there is no displacement. So students, general equation you know, work is equal to force into displacement of the point of the application of the force in the direction of force. Okay, displacement of force, suppose here in this point, application of the force in the direction of force, direction in the same direction, S is the displacement, force is applied in an object, suppose this is the object, and A to B the displacement has done, then the work is said to be done on this body. Okay, by the force, on this body by the force. On, by, these terms are very interesting and you need to remember. Now students, this is so you understand that force is applied and the motion in the same direction of force and motion same direction. But sometimes it happens that force and displacement never happen in the same direction. Maybe you are applying force in such a way, direction is another. Then how you will express the work? Then the term in your book Selena publication 2.2 subtopic expression of work, that is more properly W is equal to Fs cos theta. A term cos theta has come in trigonometry. You will properly understand what is cos theta, sin theta, tan theta. Cos theta is equal to base by cos theta is equal to base by hypotenuse. I just write as h. If there is a right angle triangle, okay, in right angle triangle, cos theta is equal to base. This is base and by hypotenuse. Okay, just remember this thing. Later I will explain. So more proper thing is that, more properly if you express the work, W is equal to Fs cos theta. But that is also correct. W is equal to Fs. When the work means when the force and displacement in the same direction, then you can say it F into S. Because there is no angle between force and displacement. Okay, there is no angle between, means angle is 0, means theta is equal to 0 degree. Cos 0 means 1. That's why W is equal to Fs cos theta. If the cos theta is cos 0, then 1 means Fs. Okay, later you will properly understand after the video. You will get a clear sense. Now just we come to understand that how we get this cos theta. Okay, so here I have written force and direction are not same. Okay, here you can see force and direction same. Okay, but in this case, when how this happens, suppose here you can see there is two ways generally it present in your book. You can check that in this case, in this condition, we can get the work done by finding component of displacement along the force, or by finding the component of force along the displacement. Okay, component of displacement along the force, or the reverse, component of force along the displacement. So what is this component of displacement or component of force? First we understand that. So here students, I will understand that what is component of force. Similar term will applied in component of displacement also. So first you understand component. Component means, students, component means you can say part of something. Component means part of something, means part of force. Suppose student, there is a point O, okay, and a force applied along this diagonal and this direction, okay, it is not parallel, along a angle F. This force is applied on a O in this point, and a motion is there, okay, means a force applied on O, F, and the displacement is O to F, okay, this is the displacement. Now students, how you calculate work done in this case? Okay, so in this case, student, if a force applied in this in an angle, you can see it, this force has two component, is the means components mean it divided into two half, you can say like that, means it has two part, one is along x direction, another is y direction. You know that in maths this is x, this is y, this is z, like this generally we practice in maths. So one component will be in x direction, this force is divided into two sub components, that and another in y direction. Now students, if we calculate cos theta from here, okay, first we just cos theta is equal to called as base by hypotenuse. Hypotenuse is this one, F force, and if we draw a line join that F with X, then this is the perpendicular 90 degree. This angle means this is a right angle triangle. In right angle triangle, if this is the force applied in this direction, then you can say from this right angle triangle, this is the base, this is the hypotenuse. Suppose this is F and we consider this as Fx, then the base by hypotenuse means H, base value is Fx by H. So cos theta is equal to Fx by H. So along the direction of X, the force will be Fx is equal to hypotenuse hypotenuse means this one, so this will be F is F cos theta. I think you can understand that along the direction of force, okay, along the x axis, the Fx force will be, that is the net force we are applying on the O, so its component along the x direction. Okay, suppose we consider this angle as theta, so along that theta, the component will be along the x direction, Fx is equal to F cos theta. Similarly, if we calculate along the y, then we need to calculate sin theta. Sin theta is equal to perpendicular by hypotenuse. If hypotenuse means, if I write H means hypotenuse, okay, so here also hypotenuse. So perpendicular. Now students, see, this is the perpendicular. This perpendicular you can parallel with this y. So if I write it Fy, then Fy and this same, okay, so it will be Fy by hypotenuse F sin theta is equal to, so Fy will be F sin theta. Now students, if we completely draw, suppose this is the point O, a force is acting this direction, then this force has two components, one in a towards x, another towards y, with the angle theta. Then we can say adjacent to the angle, this base is consider F cos theta, and it will be F sin theta, and that is the net force F. That is also known as resolution of force. So this is the way how we calculate the component. Okay, Okay, so component, this is towards fx you can say, and that is also fy. Okay, so basic thing of components. Now we come to here that now here we will calculate the work done. Work done by finding component of displacement. Now students, watch your book, figure 2.4. Okay, in that figure you can see, suppose a constant force acting on a body A, suppose this is a body A force is acting, and displacement from this point to here, you can see, suppose it is A, B and it is C. Displacement A to C. Okay, force applied here and displacement in an angle. You can see, so force we are applying horizontally, but displacement in an angular way. So you can see here, so there is an angle. Suppose we calculate the angle theta between force and displacement. Students, I told you at the very first that when the angle between force and displacement is 0, then W is equal to Fs. But when there is an angle theta, then you can write it Fs cos theta. Okay, that's why here you can see we are applying force horizontally like this way, but the displacement is in this way. You can see. So there is an angle between them. Now students, in this case the equation is Fs cos theta. So we will calculate how it has come. See students, here we will component of displacement. Just how I teach you how to find the component. Similarly student, here it is S. Here component of displacement S means along the theta it will be S cos theta, you know. Here I told you for the force, along the force adjacent with theta, that is F cos theta. So it will be S cos theta S because it is displacement, component of displacement. Okay, here we find component of force. Similarly for component of displacement it will be S cos theta. Similarly above that will be S sin theta, but we don't need that. Okay, because why we don't need that? Because we apply the force in this direction and there is a displacement. So the work done will be force into displacement F into displacement S cos theta. You know, displacement A to B. Okay. If we explain little bit, you can understand. See, suppose you are thinking this is the displacement, but we will find the component on AB. This is the B, suppose. Okay, this is the displacement, but we will displacement, you know that the minimum distance. Suppose one has started journey from here and go up to here. So displacement will be this direction, not the entire. So here to here the displacement. If we find the component along the force, we need to find the component of displacement along the force. That's why we are taking S cos theta, because you can see that is the force and along the force S cos theta. Okay, along the force. That's why we are not taking that S sin theta. We are not considered that one. Understand? So along the force the component of displacement is S cos theta, or you can see AB. That's why in your book also it has written properly. So F is cos theta. You know F is cos theta. In your book it has written like that, F into AB. AB means cos theta, and how it has come with the cos theta is equal to, you know that base by hypotenuse. Base is here and hypotenuse is by base AB by hypotenuse is. So AB is equal to S cos theta. Just I directly read it over here. Write it. I directly write it because I have already explained how to calculate the component. Now students, similarly, component of force along the displacement. Component of force along displacement, you know, force is applied here. If suppose according to this force, this object move from here to here, that is the displacement. We need to calculate the component of force along the displacement, means along this direction. Now we just along this direction. Now students, you see that will be the angle theta. Okay, means we need to calculate the force along this angle at this. If this is theta, then the opposite angle, vertically opposite angle, that will be theta. Okay, so that force is also two component. If this is the force and this is the base, then this direction will be F cos theta with the O, and another will be like this, F sin theta, but we don't need that. That will be F cos theta, student, because we are just finding component of force along the direction of displacement. So that will be F cos theta, and this displacement is S. So in this case also work done will be force into displacement. Here force will be F cos theta, displacement S is equal to Fs cos theta. Same thing, students, in your book also it has properly explained, but I just explain over here because you know that, see, similar theta will be here, that will be the base, and this is the so that is the force is acting, and this will be the base, because we draw a long, we just long the displacement line, then that will be the theta. Okay, so if we apply F here, force, that force along the theta, it will be force F cos theta. I told you along the theta base will be cos theta, and another one will be the sin theta, but we don't need that. We need along the displacement. So along the displacement it will be F cos theta, and because we need component of force along the displacement, so understand F cos theta into S is equal to Fs cos theta. Now I think you understand. Now some special cases arise from the force, that I will explain. Students, here you can see that work is equal to force into displacement into cos theta. That is the proper definition. Okay, now you can see here, if there is a displacement and force acting on an angle theta, W is equal to Fs cos theta. Already you have understand. Now some case will generate according to your book, that we will explain. First thing, you can say that if a body moving in a circular orbit, okay, just explain another two case, then one by one I will explain you. Come to the second case, when force and displacement same direction, theta is 0 degree. So Fs cos theta means Fs 0 degree means Fs into 1, cos 0 is equal to 1, cos 90 is equal to 0. Okay, that value cos value I am writing here, cos 0 degree is equal to 1, that is the maximum value of cos theta, and cos 90 degree is equal to 0, and cos 180 degree is equal to minus 1. Just remember these three value. In trigonometry you will properly understand. So same direction, that will be W is equal to Fs, means that is maximum work done, because cos theta value is maximum. So maximum work done will be there when force and displacement will be on the same direction. Now student, we will take some example in our daily life where these types of case appear. You can say here case 2. Students, when a body is free falling, okay, from A to ground B, free falling, then the work done by the gravity is equal to its mass acting downwards mg, and if its distance will be h, it will be mgh. Okay, means force is equal to mass, force into displacement h, s, so force mg and displacement s, so there will be the work done will be mgh. Okay, means W is equal to Fs is equal to mgh. So when a body, free fall body of mass m under the gravitational force from an height h, then the work done by the gravitational force, okay, or gravitational force also known as force of gravity, will be Fs or mgh. Okay, so in this case you understand force and displacement same direction, that is the force, that is the displacement, same direction it is happening, the angle is 0 between them. Similarly, another one example you can see, when a coolie is rising any substance, any weight on his head, okay, so a coolie does work on the load when rises it up against the force of gravity. Both the force exerted by coolie are upward direction. Okay, suppose there is a coolie, so he will just take the weight on his head, so same direction, upper direction it will happening, so there is also force will be mgh. W is equal to mgh, just opposite upward direction. Okay. Similarly, another one you can say that if a body revolves in a circular path under a influence of force, the completing one round displacement becomes 0. In third point, if a body, stone suppose moving in the same path, when it will come back to the original here, the S will be 0. So in this case, work done will be 0. Okay. So that is to go. Now these three conditions you understand. Now come to the third condition. That is the force and displacement same direction I have explained. Now one special case is there when force and displacement in will be perpendicular. That case also arise. With the example you can properly understand, but let's mathematically do it. So theta will be 90 degree. So Fs cos theta, Fs 90 degree, cos 90 degree value 0 means work done will be 0. There will be no work done. Okay. So when force and displacement perpendicular, in that case there will be no work done. So in this case, students, there is some example here. Earth is moving around the sun. In this case, you can see force is gravitational force, sun is pulling earth, and is displacement. You can see earth displacement every point. Here displacement will be straight this direction. Here also according to this direction. In this case, you can say the displacement and force 90 degree. So Fs cos theta, Fs 90 degree means 0, means always 90 degree, students. Okay, this is original concept. But sometime one another explanation is there, that when earth round and come back in the same position, in this case displacement 0. Okay, so that time also work done will be 0. So there is two way to explain this, that work done on the earth is 0. Okay, by the sun, because force applied by the sun and the displacement of the earth always perpendicular. This is called tangent, and this is the force is radius. In math you will learn tangent and radius is always perpendicular. Okay, so there is another case, another example for this case 90 degree, that is when a coolie carrying a load on his head. See students, suppose this is a coolie. When a carrying load and walking in this direction, then you can see, students, displacement this direction and force applying downwards. So force and displacement parallel, you can say there will be 90 degree. Displacement of this this mass, force is acting downwards and displacement parallel to the ground. So 90 degree means the work done by the coolie is 0. First one I told, when a coolie arise a load in his head. In this case, when the coolie carrying his load through on a road. Okay, when he is carrying, in that case work done is 0. But when he is rising the load, that time work done is equal to mgh. Okay, so all these things are very minute and very interestingly you need to remember. So here is also another, in this page you can understand same thing I have written once again, that positive, negative and 0 work when the same direction, force and displacement. In this case theta 0 degree means positive work. You know theta 0 degree means Fs cos 0 means 1, means positive work done. Two example, free fall I have already explained. Okay, free fall, when free falling happens, before some time I have explained. This case also I have explained, when 90 degree coolie work done gravity by the gravity is 0, or work done by coolie against gravity is 0. This case one another thing that is also that I will explain, and then the lecture will be completed from the chapter work, from the topic work. Sometimes students, a very special case happens where force and displacement, suppose we are applying force in this direction and displacement will be the opposite direction. Can you imagine? You are pushing a body and it is means force and displacement can happen opposite direction. Maybe you will surprise, but it happens. Suppose with the example I am saying, suppose you are throwing a stone upward. Now students, when the stone is going upward, gravity pulling it. So force of gravity and the upper portion going stone. Suppose that will be the displacement upward side and force is acting downward. Okay, that will be opposite. So in this case, opposite means theta 180 degree. So the work done will be negative. Okay, work done will be negative. So here positive, here work done negative, because theta 180 degree means minus 1. Cos 180 degree means minus 1. Okay, so Fs cos 180 degree, Fs minus 1. So minus Fs means negative work done when force and displacement acting opposite direction. Same direction means positive work done, and when perpendicular, zero work done. So, okay, so positive, negative and zero work done. When this condition happens, it is very much important for your exam purpose, that when the work done is positive, when work done negative, and when it is zero. I think you can properly understand. And the example of this case is throwing a stone. When you throw the stone upward, force of gravity. So work done by the force of gravity. You need to mention this, work done by the gravity. You should not mention that work done by the stone. No, work done by the gravity is negative. Okay, so I think students, you understand all the things related to the work. Next class I will talk about power. Thank you very much.